So, hello everybody. Just wanted to give a little bit of feedback before you go into your final assessment about some items that have shown up in the assignment. All right. So, just to clarify on something, this is kind of alongside the mid-semester test feedback that you would have already received. So, everything that I talked about in that is still relevant. So do have a look through that. Make sure that everything we talked about there is also, stuff that you're considering as you go into the final assessment. Now, I do have a little bit of a cough at the moment, so if I go quiet or if I do catch a cough on the microphone, then my apologies. But in any case, these are just going through some general items that we've seen thus far. So ideally, we want our pseudocode to be language agnostic. Now, that's a little bit hard when Java is your first language, right? Because it's hard to know what else is out there, what exactly all programming languages might do, what do some do differently. And that's where getting a little bit of feedback from, people like your tutors should be useful. All right, so just a couple examples of some pseudocode, and they're a little bit too close to Java. So if we look at that first line, what is wrong here? Give that a moment. What do you think would be wrong with this particular line from a pseudocode perspective? Well, thing is, scanner is a very Java specific thing. Other languages have different ways of reading user input, right? So just a few examples that I've come up with here. If you're using C, you're using this thing called printf to say, okay, what is it you want to say to a user? And then you're using something like fgetS or fscanf or scanf to actually read input from the user. Python, you're just saying input, get input from the user, so you use input. If you're using Fortran, you're using kind of this read command, right? So all of these have different ways of addressing the same thing. So usually, best thing to do for pseudocode is just to say input and output for printing or reading from the user, right? So don't worry so much about having to create a new scanner object and do all these other things. Other languages don't really want to know about what Java is. And if you think about it from the perspective of somebody who might not have picked up Java as their first language, maybe they started out with Python. If you gave them a pseudocode algorithm that said create a new scanner, they're going to go a scanner. Well, what's that for? Doesn't make any sense to them, right? So it's very Java specific. It's also worth mentioning that new is also fairly close to Java. Some languages don't use the word new at all, so that's another one to potentially avoid as well. All right, now for reading files, tends to be a very similar set of circumstances, right? Well, Java is unfortunately a little bit more convoluted than some languages when it comes to file I/O. Here we have a file input stream reader, buffered reader, and to a lot of languages, these don't necessarily make a whole lot of sense. They just don't exist, right? So another example of different languages, in C, we're using fopen to open a particular file, R for read in this case. Very similar for Python. We're opening up a file for reading. Fortran, we're doing things a little bit differently in Fortran, where every file has a number from 1 to 99, and each one needs to have a very unique number. But that aside, you can see that there's no sign of a file input stream or input stream reader or a buffered reader. So something like this is a little bit clearer. It's a little bit easier to gauge what your intentions are. Okay, we just want to open a file by the name of file name. Easy. You can, if you think it's necessary, specify whether or not it's a new file or if it's a file for reading, stuff like that, if it makes sense to do that in your design. But for our purposes, this here works well. You're opening a file, don't need to go into the details about what exactly Java is doing. So those are the main pseudocode things that I'll point out, in addition to, again, what we talked about in the mid-semester feedback. So the feedback here, again, is just kind of building on top of things you've already seen. So let's move on to the Java code. And I'm going to focus on just a couple of topics here: aggregation and exceptions. So remember, aggregation is when you have an object inside another, which is something that happened with something like your location class. Now, what's a potential issue that might happen here? It's a little bit of a subtle one, right? We're returning our location, which is in our case here, a class field. So that's just all what mLocation happens to be. It's just a class field. Presumably, this would be in your accident class. So if we go into a simple main, let's have a look at this situation. So we create a new accident class, just assuming that we're giving it all the proper information. And your assignment, this would be done in your file IO part, where you're reading in a line, converting that, and creating an accident based on that information. But here we're just going for something a little bit simpler for demonstration purposes. On line 9, we get the location. We use a set latitude to set the latitude to something else. Then we print out both of these. Now, the trouble is, at this point, we ideally want this to be a copy of our location class, right? So if you remember from the lecture slides, in all the pseudocode, it says export a copy of this thing, export a copy. And that is very important here, because when you come to these two lines, if you're not returning a copy, these are going to print out the exact same thing, even though it might seem like these are two different locations, right? We got a location from our accident, so there's a location inside of our accident, there's a location outside of our accident, but they're really the same thing. They're looking at the same sorts of they're looking at the same part in memory is what's effectively happening. You don't need to worry about the memory side of things, but it's important to know that if you're not creating a copy, that's the kind of side effect that might happen. So that's my feedback there, is to make sure that you are returning a copy. So how do you do that? Well, you have a copy constructor, right? So if you use the copy constructor to create a new location and then return that new location, you don't end up with those excuse me. So you don't end up with those side effects, right? Because this is a new location object. You can change this as much as you want. It's not going to affect our accident class unless we wanted it to. We're accessing the accident class specifically to change it. That's when we might want to change it. But outside of that, we typically don't want this thing to happen. We don't want something like this talking about the same object. We don't want to have to keep that in our minds. That's more cognitive load. It opens us up to more bugs, more mistakes. Now, speaking of constructors, let's have a look at this one real quick. So just a slightly simplified version of what you might see in your assignment. So location, I'm getting in two doubles and I'm setting them to member fields. So I've called the member fields in this case mlat and mlong. So what's missing? Validation, right? Because we're not checking to see whether or not these are valid values for latitude and longitude. So always make sure that you're validating. Validate your user input, validate your classes. Now you can ensure that the object is valid like this, but if it's not, you have a few options, and not all of them are great. One is you could set it to like some default values, but then you're kind of hiding the issue. You're sweeping it under the rug so that it makes you create a location object. You've got it there. Is it the location object you thought it was? No, it's got some default values, but we're not going to tell anybody that. Not a great solution, right? So ideally, we want to stop it from being created in the first place. Don't create it whatsoever, right? So you could do something like this, where you have a isValidLat and an isValidLong method for those two parts. You check to see if the latitude is valid, and you check to see if the longitude is valid. And if one of those is not, you throw an exception, right? So anytime you throw an exception, that stops the execution where it is, right? So we're not going to create a new location class object here, right? So if we check about how this is actually used, so this is again kind of a simple example. It's not exactly what you would have seen in your assignment, right? We're not just typing in latitude and longitude and creating a location object from that. We had file IO. But for demonstration purposes, just for this bit of feedback, let's have a look at this example. So we get user latitude, we get user longitude, and then we try to create a new location class or location object rather, using that information. Now, if the user happened to put something invalid in there, so they put in 9,999 for latitude, we don't want to just create the location object and silently have something that's kind of defective. We want to stop it then and there. And that's what our throw here does. It stops it. But on this point of view, we just want to check if it was created or not. So we're using our try and catch here. If we catch an exception, we know something went wrong. And whatever we do here is up to your design. This is just a simple example of saying, all right, invalid location. Yeah, I mean, this is not especially useful. You could use loops in order to use these exceptions, similar to what we've discussed in the past about using exceptions for user validation to keep asking for valid numbers and then create our location object. You could, count how many times something's invalid. You could do anything like that here, right? So whatever is put in that catch is your contingency plan. If you've tried to create a location and you failed to do that, what do you do now? It even matter. Just suddenly drop that and say, well, if we can create that object, no worries. Let's go to the next line. That's another valid strategy, especially for file IO. Couldn't read a blank line? Oh, well, go to the next line, try again. Rather than just saying, oh, well, the first line that we tried to read was invalid, had some invalid data we won't read at all, right? Then you don't end up with anything useful to use. So what you do here is, again, up to you. Now, I think one of the trickiest things is deciding when do you try and catch and when do you throw. And that is a little bit of a matter of experience. You're looking at the separations of concerns for what you're designing. For our case with the location object, it doesn't know what you want to do in the case that an invalid object is trying to be created. It just says, you tried to create something wrong, I'm going to let you know. This goes up a level, goes up to whoever tried to do this, and they say, okay, what we just tried to create was invalid. How are we going to handle that? In this case, we just print out a error message, but you could make this more complex. You could make this more robust and user-friendly. So those are the main bits of feedback that I wanted to give you guys before you go into the final assessment. Again, do have a look over those mid-semester feedback. Make sure you're doing those things that we discussed there. Everything that we talked about here is kind of building on top of that. This is just talking about some more specific issues that we've seen with assignments. Just something to keep in mind as you go into that final assessment. That's all I have for now. Best of luck, everybody, in the upcoming final assessment. Thank you so much for a wonderful semester, and I will see you later on. Bye for now.